Welcome back, folks. So in this video, I'm going to be focusing on shared pointers. So dynamic memory allocation has always been a rich source of bugs because you could end up forgetting to release memory. And that's where the concept of shared pointers is going to help us. So shared pointers uh, takes the pain out of managing memory manually, and all that you need to do here is to initialize a shared pointer, and internally a count is maintained. So as pointers keep pointing to the same object in memory, this count gets incremented, and finally, when there are no more pointers pointing to the memory object, um, the memory is released. So it's up to the compiler how this is internally implemented. So some compilers might use reference counting, and it's completely implementation dependent. So let's look at how we initialize a shared pointer. So I've got some code here, starter code. So as you can see, you have shared pointer class, and it's a template class. So we have focused on templates previously. So all that you need to do is you need to, in this case, what I'm trying to do here is I'm trying to create a shared pointer to an integer. So the shared pointer template is instantiated with an integer, and I also use another inbuilt function, which is nothing but the make shared function. The make shared function actually returns a shared pointer to this integer. So my integer is 55 here, and I'm actually creating a shared pointer to it, and that pointer is stored in this variable shptr1. All right, so how exactly do you reference the value of what's stored in this pointer? All that you need to do is dereference it the usual way by using the dereference operator. All right, so there I will show how that is done in a short while. So let's also see what happens when we initialize another new pointer, a new shared pointer to this existing pointer. So it's something like this: shared pointer. Going to create another shared pointer, say shared pointer 2, and I'm going to initialize it with what's there in shared pointer 1. All right, so what do you think would happen? So since this shared pointer is also pointing to the same location as shared pointer 1, we have two pointers now pointing to the same memory location. So the reference count would have internally increased, and the count would now be, how do we check, well, how do we check the count? So we have this function called use count. So we have shared pointer dot use count, which will actually tell us how many pointers are pointing to that specific location in memory. So let's check it here as well. So shared pointer count is, and we could use shared pointer 1, or you could use shared pointer 2. It doesn't really matter because it's all going to be reflecting the same reference count. So in this case, let's use shared pointer 2.useCount. Okay, now there's one more use case. What happens if we pass the shared pointer to a function? So I have got a function here called display. So as you can see, this display function takes in a shared pointer as one of its parameters. So I'm going to call that function from the main function here. So I'm going to say display, and as you know, it expects a shared pointer. So I'm going to pass one of these pointers. So let me pass shared pointer 2. All right, and that's it. And what does that function do? The display function, it just outputs the value. And as I told you previously, all that you need to do is use the dereference operator. So we are also once again checking the reference count, and this is going to tell us how many pointers are pointing to that very same memory location. So what happens when the function call uh, returns and you're done with the function? So this function pointer here, this pointer here, this shared pointer here, the scope of it is only this function. So as soon as this function completes, this shared pointer variable goes out of scope. So in other words, we have only two pointers pointing to that memory location. So let's check that out as well. So let's print the pointer count after the function call. So after the function call, it should definitely decrease. Just for the sake of completeness, let's also try it with shared pointer 1. So the function to remember is use underscore count. All right, so let me remove these unnecessary spaces here. And I'm just using namespace std for the because it's easy to do that. I'm a bit lazy and I'm using that, but you should never use the entire std namespace. So we should not be doing this. We should ideally be doing something like std cout, std cout, and this would also once again be something like std. And yeah, so for the sake of uh, doing things a little faster, I'm just going to be lazy and pull in the entire std namespace. But in production code, you should never be importing the entire std namespace. All right, so let's set a breakpoint maybe here, or let's just let's set a breakpoint and see what happens. Okay, so let's run our program. Okay, so the first cout has executed. So let's see what yes, and so as expected, the shared point counter is 1. So now let's execute it further, and now we have initialized the second pointer. So let's see what our count is going to be, and as expected, the count is incremented to 2. Now we're calling the function called display, and let's see what happens there. So it's called, and let's see what the value is. The value is 55. Awesome. Now within the function, let's once again output the shared pointer count, and as expected, the shared pointer count is 3. Excellent. So now we have come out of the function call has completed. So as I said, the shared pointer, one of the shared pointers has been destroyed. So let's see what the count is. Yes, as expected, now it has decremented to 2. And this should once again give, the next statement should also give 2. Yes, that's as expected. It is 2. So that's it, folks. This is a very important topic when it comes to memory management. So this is how you use shared pointers. You basically make use of the make shared function to create a shared pointer. So it's not just integers here. I've used a very simple example. You can actually create shared pointers for pretty much even your own classes. So it could be, say, a shared pointer to say some class that you define. uh, all that you need to remember is that you have to use, and obviously you have to be able to pass um, the values which will initialize an object of my class. So let's assume that you have to pass, say, maybe an integer and maybe a float and that sort. So let's assume that we have a class here, say, which is my class. Okay, and it has let's assume it has two variables, an integer and a float. All right, and let's also write a constructor for it. My class, which takes an integer v1 and a float v2. So a is initialized with v1 and b is initialized with v2. That's it. That's our constructor. Okay, so this is a pretty dumb class, and as you can see, so that's how I initialize a shared pointer to a user-defined class. So all that you need to do is like call the make shared function, template function, pass um, the um, the type of object that you are trying to instantiate within the angle brackets, and of course then call the constructor to that specific type. So in this case we are calling the my class constructor and passing two values here. The first is an integer and the second is a float. So maybe let's, for the sake of completeness, let's look at the count of this shared pointer as well. uh, okay, let's see the count of uh, the shared pointer pointing to my class object. Okay, is should be shptrx dot okay dot use underscore count, and let me add a new line at the end. Maybe I can just create one more shared pointer x, let this be a different. All right, and let's see what happens. Let's set a breakpoint here. Let's run our function. Okay, so we have initialized, yeah, the shared pointer here, and the shared pointer count is, let's see what the shared pointer count is. The count of the shared pointer pointing to a my class object is 1. That's because we are only looking at shared pointer x dot use count. As you can see here, we have created a shared pointer which points to this object, and then the second shared pointer is actually not pointing to the first one, it's pointing to a new object. So what we get here is just the count for the first shared pointer. So let's try something. Instead of creating a new object here, let me just point it to shptrx. Now what would you expect the count to be? The count is going to be 2. So let's see whether we get that. The count of the shared pointer pointing to a my class object is 2. So as you can see here, we have 2 pointers pointing to the same my class object, and that's the reason why you get the count as 2. So I hope you enjoyed this video and now understand shared pointers a little better. This is a very important concept, and I hope you will continue exploring it. Thank you, and let me see you in the next video.